Every day we learn one PCB fun fact. Today, we're diving into LDI. LDI laser direct imaging is a revolutionary digital process for pattern transfer in PCB manufacturing that uses computer-controlled ultraviolet laser beams to directly project circuit patterns onto photosensitive resist, dry film, liquid photoresist, coated PCB substrates, eliminating the need for traditional photomasks of films. After exposure, development, and etching, high-precision circuits are formed. The workflow involves software parsing Gerber design files gives laser beam precisely controlled by a digital micromirror device. DMV gives selective exposure on substrate surface, gives photosensitive resist. Cured by light gives development to remove uncured areas, gives circuit pattern formation. LDI typically uses UV lasers with wavelengths of 355 nanometers, 405 nanometers, or 248 nanometers, achieving micrometer level focusing accuracy and stable minimum line width, space of 6 micrometers, or even 5 micrometers, far exceeding traditional film exposure limit approximately 25 micrometers. Key advantages include maskless operation, eliminating defects from mask deformation, scratches while reducing costs and lead times, ultra-high precision, with pattern alignment error is less than or equal to plus or minus 3 micrometers. Ideal for high-density products like HDI and IC packaging substrates. High efficiency and flexibility. Product changeover takes only 5 minutes versus hours for traditional methods. Supporting small batch multi-variety production. Digital control with fully traceable exposure parameters for process optimization. Mainly applied in high-end PCB manufacturing, such as 5G communication boards, server motherboards, automotive electronics PCBs, medical device PCBs, and other fields requiring strict circuit precision and reliability. LDI is a key technical enabler for the PCB industry to move towards digital and precision manufacturing.